So the video today is going to be 4.1 about radians, degrees, and arc length. As we go through this, there will be some material that is optional. I will try and highlight that so you know what that is. And then you don't have to do those problems from the homework. There should be a regular homework assignment and then an optional homework assignment on Schoology. So for the warm-up, think about why do we divide a circle into 360 degrees rather than some number like 100 or something else that would be easy to divide it into. So think about it for a second, and then I'll go through some of the different theories about why. So the first theory comes from the idea that there's about 360 days in a year. So you noticed, you look in the stars in the sky, each day the stars move a little bit, which then relates to about 1/360th of a circle, or 1 degree every day. Another option is the Sumerians. They used a base 60 in their counting system, so you can divide a circle evenly into 6, and then take that and divide it into 60, and you keep going, you get 360. The last idea, which probably makes the most sense, is that 360 can be divided by a ton of different numbers. So you can divide it by 1, 2, 3, 4, etc., all of these numbers right here on the bottom. And so you get a lot of nice fractions, which is better to deal with than like weird fractions. So this chunk here, I'll highlight it in red. This is an optional slide. Try and put red next to each of the optional slides. So here we're going to talk about degree measure versus the DMS measure. DMS stands for degrees, minutes, and seconds. So if you look at this first degree right here, we have 97 degrees. Of those 97 degrees, we have 5/10ths of a degree and 3/100ths of a degree. So then on your degrees, minutes, seconds, you can do a similar idea. We're going to have 97 degrees, 31 minutes, and 48 seconds. And this works the same way like minutes and seconds do on a clock. So for your minutes, that's going to be 1/60th of a degree. And then your seconds are going to be 1/3600ths, or say 3600ths. This comes from taking 1/60th to get a minute, and then times 60 seconds in a minute will give you your 1/3600th. So continuing on, this is still your optional information. You can convert between the two of these. So looking at this first one, we're going to get 47 degrees right off the bat because you have a 47 right here. So 47 degrees, and then we have to figure out how to get our 0.5 into minutes and seconds. So if you have half an hour, you can multiply by 60 to get 30 minutes. The same idea applies here. So you can take 0.5 times 60, and that's going to give you your number of minutes, which is going to be 30 minutes. Here we're done because we're a nice even number. There's no decimals, nothing else we need to do. If there was decimals, we would need to continue on. So at this point, pause the video and try 120.15 degrees and 14.22 degrees, and then check your answers with me. Okay, so again, 120 degrees, and we're going to take 0.15 times 60 to figure out the next chunk, and you're going to get a nice even 9. So you get 9 minutes. This next one, we have 14 degrees. Take 0.22 times 60, and you should get 13.2, I believe. Now we have an extra decimal, so you're going to have 13 minutes, but then you have to take this 0.2 and do 0.2 times 60 to get the next chunk, which will give you 12 seconds. So if you have an extra decimal, just keep going until you get a nice whole number. And then you can go backwards in a similar way. But instead of multiplying by 60, we're going to divide by 60. So if we have 5 degrees to begin with, we still have 5 degrees over here. But then to take the 14 minutes into decimals, you want to take 14 divided by 60, and that will give you your decimal portion of 0.23 repeating. So now try these next two on your own. Pause the video, and then I'll go through them. Okay. So we get 28 for our standard degrees again. And then if we want to figure out the rest, we have two chunks here. So you have 14 over 60, and then you want to add on 33 over 60 squared, or 3,600. And that will then give you the decimal for the next chunk. If you type that into a calculator, you should get 0.2425 for this one. And the last one, you should get 143.0153. Here there's no minutes, only seconds, so you're going to do 55 over 3,600. All right, so an interesting side note. So a nautical mile is not the same as a regular statute mile. A nautical mile comes from 1 minute of arc length around the equator, so like moving around the equator versus just a straight distance. So degrees are not the only way to measure angles. There are other ways to measure angles. One of them is radians. So you've talked about this last year in advanced algebra, but where do radians come from? So think about it a little bit, pause the video, write down an answer. All right, radians come from the idea of pi on a circle. So if we have a circle right here with a radius of 1 full time around the circle is going to be 2 pi. So if I start here and go all the way around, that was 2 pi radians, or like 360 degrees. So you can take a circle and divide it into chunks of 2 pi, or chunks of the 2 pi radians, and get different measures of the circle. So it's like degrees, except it's just a different way of measuring, kind of like inches versus centimeters. You can do degrees or radians to measure the angle that you're looking at. So to convert between the two of them, you can think of this here. 2 pi goes all the way around the circle, and 360 goes all the way around the circle. So this is your degrees and your radians to go once around. So if we want to go from degrees to radians, we're going to start with our degrees here, and then we need to multiply by something to end up in radians. So we have 360 degrees is the same as 2 pi radians. Here, if you go back to dimensional analysis from chemistry, your degrees are going to cancel, and you'll end up with radians. And if we simplify this, your conversion is going to be pi over 180. So use this to go from degrees to radians. So I want to take 150 into radians. I'm going to multiply by pi over 180, which then will simplify to 5 pi over 6. To try the next one on your own, pause and then check with me. So this one, if you have negative 100, multiply by pi over 180, simplify down, and you should get negative pi over 9 as your final answer. So in going the opposite direction, radians into degrees, you just want to flip your conversion. So 180 over pi instead of pi over 180. So if we have pi over 6, multiply by 180 over pi, and that will switch you back into degrees. I can write this. Here the pi's are going to cancel, so you end up with 180 over 6, which will then simplify to 30 degrees. So try this next one on your own and then check with me. So you take 5.9 times 180 over pi, put this all into a calculator, and you should get 338.05 degrees. All right, next we're going to talk about arc length. This, again, is going to be an optional chunk. So from here on to the end of the notes is all optional. So if you want to stop here and start your homework, go ahead, or you can keep watching. So arc length is the length of an arc, like it sounds. So this S right here, you could figure out how many inches or how many centimeters or miles that arc is. It's usually given by the letter S. So there's different formulas depending on if your angle is in degrees or radians. So if your angle is in degrees, you want this formula, or here's the abbreviated one. It comes from your total circumference multiplied by what the angle is, or what portion of the circle you have. Here's the formula for radians, which simplifies down into a nice, easy r times theta. And so here we can do an example. So you're given a circle of radius 4. The central angle is subtended by a 6-foot arc. We want to figure out what's the angle measure. So here, it doesn't tell us what here it does say we want to find our angle in degrees. So we need to use the degree formula. So we have that the arc equals pi times the radius times theta over 180. So you can then plug in what you know. So we have a 6-foot arc, we have pi, and we know we have a radius of 4, theta, and then 180. So at this point, you can just solve this equation. So multiply by 180, and then divide by 4 pi, and you'll end up getting a theta of 85.9 degrees. So here's this next slide. Think about this by yourselves. So we have a carousel. One person is sitting right on the inside, one person sitting right on the outside. And then answer these two questions. Is one person spinning faster than the other? And is one person traveling faster than the other? Okay, so the answer to the first one is yes. The person on the outside is traveling faster because she has a larger circumference to go around for each spin, but they are not spinning faster than each other. They're going the same spinning speed because they're doing the same revolutions around the circle. So that brings us here to angular versus linear speed. So angular speed is the speed of revolutions per minute. So how many times you're spinning around the circle. So this would be your spins. And linear speed is how fast are you actually going, like meters per second, kilometers per hour, that kind of thing. So this is your standard speed or your traveling distance from the last example. So we're going to do 2 examples here of using this, and I'll be some dimensional analysis. So here, Bill's circular saw has a radius of 20 inches, spins at 1,000 RPMs. Jill's has a radius of 6 inches and spins at 2,500 RPMs. So we want to figure out who has the fastest moving teeth. So we want to figure out some sort of speed versus like our angular speed. We want the linear speed. So start here. If we have 1,000 RPMs, it's revolutions per minute. You then want to get rid of these revolutions and convert to something else. So 1 time around the circle is going to be 1 circumference. So we have 1 revolution is 1 circumference, which is the same as 2 pi times the radius. So 2 pi times 20. This again is our circumference. And it says that it's 20 inches, so our units here is inches. So at this point, we're getting rid of revolutions and switching to inches per minute. If it doesn't tell you like what kind of speed you need, you can be done here. So it might say like it wants in hours per, or like feet per minute, that kind of thing. Then we would have to convert to feet. But at this point, we don't. So if you type this into a calculator, you should get 125,600 inches per minute for Bill. And we're going to do the exact same thing for Jill. So 2,500 RPMs for each minute. And you want your circumference on top. Rewrite that. And she's going 6 diameter. Type this all in, and you should get 94,247 inches per minute for Jill. So who's moving faster? Bill's saw. So our final example here. So Bill's saw is going like this fast. We want to figure out how many is that in feet per second and miles per hour. So start with the number you have. We have inches on top, minutes on the bottom. So if we want to go to feet per second here, we know for every minute there's 60 seconds. So 1 minute, we want the minutes on top so it can cancel here, is the same as 60 seconds. And then we want to get from inches to feet. So inches is on top, so we're going to put inches on the bottom. So you have 12 inches to 1 foot. Your inches can cancel. Our leftover units here are seconds and feet, which is what we wanted. So then multiply straight across here and straight across here, and you'll end up with your answer. You should get about 174.53 feet per second. And we can do a similar idea for miles per hour. So here I'm going to start with our feet per second stuff. Actually, we'll start with the other one. So you have this again, our inches per minute. So if we want to go miles per hour, we have 1 minute for 60 seconds. And then backwards. We have 60 minutes and 1 hour. And then you have 12 inches and 1 foot. I'm going to drop down here. And then we're now inches, so our inches are gone, our minutes are gone. We now need to get feet to miles. So you have 5,280 feet for 1 mile. So our units left over right now are hours and miles, which is what we wanted. So type everything into a calculator, multiply across the top, then multiply across the bottom and divide. And you should get 118.98 miles per hour. This up here, I think I have the decimal in the wrong place. It should be right here for your decimal. All right. So ignore this assignment. Look on Schoology to figure out what the assignment is. There's a regular assignment and an optional assignment that you can do, and please submit them on Schoology when you're done.